We know that an electromagnetic wave is a traveling disturbance of electric and magnetic fields. But now let's look more closely at the wave itself. A wave repeats itself from one point on the wave to the same point in the next cycle. We have one complete cycle. The number of cycles that happen in 1 second is called frequency. Frequency tells us how quickly the wave oscillates. 4 cycles in 1 second means a frequency of 4 Hz. A low frequency wave changes slowly. A high frequency wave oscillates more rapidly. Now, instead of asking how fast the wave oscillates in time, let's look at the wave in space. The distance between two identical points on consecutive cycles is called the wavelength. So far, we have seen that the wave speed is related to frequency and wavelength. But electromagnetic waves are special. In free space, they travel at the speed of light, which is approximately 3 into 10 to the power 8 meters per second. We represent this speed using the symbol c. Now we can connect the three ideas. Wave speed is equal to frequency into wavelength. For an electromagnetic wave traveling through space, the speed of the wave is the speed of light. C equals to F into lambda. Now let's look at what this means on the wave. The distance between two identical points on consecutive cycles is the wavelength, which is lambda. Because the speed of the wave is fixed, frequency and wavelength must adjust to each other. Higher frequency means more cycles in the same 1 second, so the wavelength becomes shorter. Lower frequency means fewer cycles in the 1 second, so the wavelength becomes longer. This relationship is everywhere in wireless communication. Different wireless systems operate at different frequencies. Because the speed of the waves is fixed in free space, each frequency corresponds to a particular wavelength. This is why engineers constantly talk about both frequency and wavelength. Wavelength is not just a mathematical number. It becomes important when we design antennas. It also affects how electromagnetic waves propagate through space and interact with obstacles. And all of this becomes part of the wireless system design. But all electromagnetic waves don't have the same frequency. From radio waves to visible light, the electromagnetic world covers an enormous range. Every region corresponds to a different range of frequencies and wavelengths. In the coming episodes, we will explore that spectrum.